In this video, we're going to be solving some different application problems that are with quadratics and polynomial functions. They're both very classic examples of how we can use polynomials and quadratics in order to solve these types of application questions. So the first example has a backyard farmer that wants to enclose a rectangular space for a new garden within her fenced backyard. Sorry about that. She has purchased 80 feet of wire fencing to enclose the three sides. I'm going to label my diagram with that. So here's my garden. And I have 80 feet that can go right here. The fourth side is going to be the fence, so we don't have to worry about putting any wire back there. What that means, I'm going to label this also with an L, is that L plus W plus L, or 2L plus W, must be equal to 80. The big question is going to be, that I forgot to include here, is what is the maximum area of garden that she can create? Well, area is going to be length times width. So let's go ahead and solve this for W by subtracting 2L. And then let's substitute in for W here. If I distribute L, then this is the quadratic function I would get. And if you're having a hard time seeing it as a quadratic function, we can rewrite it in terms of x and y that you might be a little bit more familiar with. Since this would then be a parabola that opens down, the maximum would occur at our vertex. The vertex of a parabola occurs at negative b over 2a. So negative 80 over 2 times negative 2. Negative 80 over negative 4 gives me 20. And in place of x, I did L. So a length of 20. And then I can find out what my width would be. And that's going to give me my maximum area. Another way that I could have solved this as well, just for reference, is I could have factored out a negative 2x and seen that the zeros of my quadratic would be at 0 and 40. The vertex, or the maximum of a quadratic, will always be in between those two zeros, which would have been 20 as well. So either way, you could have solved the problem by finding 20, either using the vertex formula or using the zeros. All right, let's look at another example. An open top box is to be constructed by cutting squares out of each corner of a 14 centimeter by 20 centimeter sheet of plastic and then folding up the sides. So it's going to look something like that. Okay. Find the size of squares that should be cut to maximize the volume enclosed by the box. Well, one thing that I want to make sure that we see is once we cut out W here and that exact same here, then the length that is left here is 14 minus 2W. Okay. Same thing here. When I cut out W from both sides here, I get 20 minus 2W. And then when I fold up the sides, the height is going to give me W. All right, so I want to maximize volume. Volume is equal to length times the width times the height. So 14 minus 2W, 20 minus 2W times W. If that's a little bit yucky, you can also change this into X's and Y's, just like so. Now, my leading term is going to be 4x cubed. My zeros, let me scoot this down just a little bit to give me some room. My zeros are going to be at x equals 0, x equals 7, and x equals 10. End behavior. And then all of these are just multiplicity of one or linear terms. So it's going to look like that. Therefore, the maximum that I'm going to want to look for is this piece right here. All right, we could take a guess and see what that 0 might be. That's going to be somewhere between, or excuse me, where that maximum might be. It might be between 0 and 7. But I'm going to plug this into Desmos and see. Maybe I'll play around here with my window. See, I just want to go from maybe -5 to 15. And then maybe -20, and then it looks like I need to go pretty high. All right, so here is my maximum. And it's a good thing I didn't guess, because I would have said maybe halfway, which is 3.5, and it's not quite. It's 2.704, and then here is my maximum volume as well for our problem. All right, so if I come back to our problem here, I know that this maximum value is going to occur at x, or w, I should say w, equals 2.7 centimeters. And if I cut 2.7 out of each one, that's going to maximize the volume of my box.